the abundance of chemical elements in the universe. The number one element is hydrogen. The number two is helium, which is not chemically active, but it's there, but it's a big number two. Number three is oxygen. Number four is carbon. Number five is nitrogen. One other fact, which is not often cited, but it has to be in the equation, is, the earliest fossil evidence comes in around 3.8 billion years ago, and Earth began 4.5, 4.6. So for the longest while, decades, people subtracted those two numbers and said, all right, life took 600 million years. That's still pretty fast, given that we're 4.5 billion years old. Okay, that's still pretty fast. It's small compared to the life expectancy of Earth. But it's even better than that, because the early Earth was subjected to what we call the period of heavy bombardment. There were two such periods. Heavy bombardment, Earth is still, the polite way to say it is, accreting matter from the nascent solar system. The more violent way to put it is being slammed constantly by comets and asteroids, because it has a strong gravity in its region. It's clearing out its orbit, and all that material ends up going somewhere and it lands back on Earth. And so the Earth is gaining mass, and by gaining mass, it gains even more gravity. It becomes even better at it. And over that time, Earth's surface is sufficiently pelted that the temperatures prevent the formation of complex molecules. Because under high temperatures, the molecular bonds break. And every time you try to experiment with it, it gets broken apart. So it's not conducive to the experimentations of life. So if you're going to start the clock, wait until the period of heavy bombardment is over. That's like 4 billion years ago, not 4.6. So now you start the clock. Now Earth has some chance of cooling down and making complex molecules and starting the birth of biochemistry. And there it is. Earth went from organic molecules to self-replicating life within between 1 and 200 million years in the early universe.